Dear students, today we are going to derive the equation of a plane passing through 2 points and perpendicular to a plane. Plane amada point ani faraga satba ko aduga atoba plane amada perpendicular taba sigi equation of the plane derive tawdoine. Let a1 vector and a2 vector be the position vector of the 2 points A and B on the required plane, which is perpendicular to a given plane, and the equation of the given plane is r vector dot n1 vector is equal to q1. Equation number 1 tare ko. Nangi plane am laitadi normal am laibam tho a let n vector be a vector normal to the plane. Sigi nangi require plane sida normal or riba vector se n vector oreko, and so this n vector is perpendicular to kanada perpendicular tagani ab vector. Ab vector means a vector formed by joining the given 2 points A and the B, and this n vector will be perpendicular to n1. Sina require plane is sina given plane ni ko. Sigi n vector se AB vector dasu perpendicular oigani, n vector se n1 vector dasu perpendicular tare figure sigi matungina ko. And so this n vector is given by cross product of AB vector and n1 vector. AB vector means position vector of B minus position vector of A2 minus A1 ko into cross product of n1 vectors minus nangi n vector ang fangi n vector se kaino n vector is a vector normal to the required plane, and so write the equation of the plane passing through a1 vector and normal to the n vector. Nangi plane ama sina nangi plane sina point ama fauraga satpa n vector the normal oibase karamba equation na pigi r vector minus a1 vector dot n vector is equal to 0. Sina nangi han hanba equation of the plane derived to form do tare ko. R vector minus a1 dot n vector is equal to 0. R vector minus a1, then replace this n vector by kaina sintare a2 vector minus a1 cross product of n1 vector will be equal to 0. And equation number 1. Equation number 2 and this is which is the required equation of the plane in the vector form. Sinang na ngasay putong nangiba equation of the plane dune. Plane to the point kya legi A ga B ga legi mana atopa plane amada perpendicular tai ko. Mathang da sigi equation se akoina kaida onthokadaba Cartesian da muk derive tawbagi mawang se ko. Now we are going to derive the Cartesian equation of this plane. Cartesian equation a1, a2. a1 means position vector of the first point represented by x1 I cap y1 and z1. a2 position vector of b dune ko adun x2 I cap y2 z2 lower say n1 habedi kaino n1 vector be a normal to the plane 1. Plane nangi require given plane the perpendicular taba normal amani direction ratio se ABC and Loreco R vector means position vector of any point on the line. Unknown quantities are represented by x, y, and z, and so R vector is equal to xi cap plus yj cap plus zk cap si Loreco. Nangi equation 1 the puthokadaba expression je R vector minus a. R vector minus a haitardi R dagi a1 khaidoksiko x minus x1 I cap y minus y1 j cap and z minus 1 j k cap. Next, a2 minus a1, x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 magi component sing se subtract ko. And so the equation r vector minus a dot a2 vector minus a1 cross n1 vector equals to 0 becomes. Sige equation ja kaita sense tawrakani r vector minus a2 vector minus cross product n1 scalar triple product type sigi vector siga atopa ani sigi cross product gi marakta dot product lawi ko dot product of one vector and cross product of any two vectors se kai kawi scalar triple product se 0 ga manare. Scalar triple product of three vectors in terms of their component is equal to expansion of a determinant. Determinant amagi expansion gamane and elements are given by first write the components of r vector minus a, x minus x1, y minus y1, z minus z1. Then write the components of second vector a2 minus a1, x2 minus x1, y2 minus y1, and z2 minus z1. Then write the components of n1 vector. They are a, b, c is equal to 0. Sigi determinant se expand tawraganda koina x, y, z haiba equation am phangni ko. We will get a first degree equation in x, y, and z, and that equation will represent the equation of the required plane in Cartesian form. Cartesian form the segi equation jina pirani. Mathangi question je mo yengse. Derive the equation of a plane passing through a point and perpendicular to the two planes. Nangna plane ama derive tawgadaba. Plane sina point ama pharaga satpa ko. Atoba plane anida perpendicular taba. Figure si yengase ko. See require plane. This require plane is perpendicular to the two planes. Plane 1 and the plane 2. Plane anista ma perpendicular ta. Figure sigi matungina ko. Aina hojik derive tawduse mayaider lairiba plane sini. Sigi plane si the point ama laire. Point sigi position vector se a. Si khatani nangon piri se ko. Let a vector be the position vector of a point A on the required plane. Nangi required planes the labor point namane and which is Canada perpendicular y, which is perpendicular to the given two planes. Equation of the first plane r vector dot n1 vector is equal to q1 n. Equation of the second plane is r vector dot n2 vector is equal to q2 smina. Nangi equation of the plane ani pire ko, and let n1 be a vector normal to the plane. Nangi n vector se vector ramani kanada normal oiba nangi required plane sida figure se gi matungina n se nangi required plane the perpendicular tare n1 vector be a vector normal to the plane 1 and n2 be a vector normal to the plane 2 sigi figure se yengba kanda sigi n vector se kanada perpendicular oi. From the figure we see that this n vector is perpendicular to n1 vector and n2 animakta perpendicular tai ko. So this n vector is given by n1 vector cross n2 vector amana atoba vector ani the perpendicular oiragadi vector do n1 vector cross n2 have the cross product of two given vectors to na pirakani ko. See ito a, then write the equation of the plane passing through point A and the normal to n vector. Sige formula sing upan se ko. Equation of the plane passing through a vector and normal to n vector is r vector minus a vector dot n vector is equal to 0. Sitare ko r vector minus a, then replace this n vector by kaina sintare n1 vector cross n2 vector is equal to 0. Equation number 1 thare ko, and which is the equation of the plane in vector form. Stefangi equation of the plane se vector form neba. Hobjing makata na koina kai derive tawgani. Now we are going to derive the Cartesian form of the plane. Cartesian form amuk derive tawse ko. Cartesian the a vector haibamga r haibamga yawi. A vector means position vector of the given points on the plane, and so they are represented by x1, y1, z1. My component sing duniko component form the express tawragadi x1 I k plus y1 j k plus z1 k r vector. R vector means position vector of any point on the line. Unknown points niko. The unknown oibanine x, y, z na represent tawre n1. N1 be a vector normal to the plane 1. So direction ratios are a1 I cap, b1 j cap, and c1 n2. Direction ratios are a2 I cap plus b2 j cap plus c2 k cap. See expression si darkar oiba ke koina loi ito ko. And now r vector minus a. The value of the expression r vector minus a is equal to x minus x1 I cap, y minus y1 j cap plus z minus z1 k. Sima phangi ko. Mathangda si puthokpa loibadagidi, then the equation r vector minus a dot n1 vector cross n2 is equal to 0 becomes kaida sense tarakani si so scalar triple product tai ko. R vector minus a ne n1 ne n2 ne r vector minus a. Write the components of r vector minus a. X minus x1, y minus y1, z minus z1. Si thoe ko mathang the n1 gi component iro a1, b1, c1. Then write the components of kanagi component igani n2 gi ko a2, b2, and c2, which is equal to 0. And see expand to running expand to rakanda kweni x ne y ne z ne have a equation am phangani ko. We will get an equation involving x, y, and z, and that equation will represent the equation of the plane passing through a given point and perpendicular to two given planes. Nangi plane anida perpendicular taba. Hosing makata na kwena miscellaneous exercise yengsiko. Miscellaneous exercise ki question number 6 yan yengase. If the line ani pire ko. If the two lines are perpendicular, then find the value of k. Nangon the line ani pire, line ani se perpendicular oiragadi kaigi value putho haiba, find the value of k. First write the equation of the given lines. Equation of the lines are x minus 1 by minus 3. y minus 2 by 2k, and z minus 3 by 2. Write equation number 1, x minus 1 by 3k, y minus 1 by 1 is equal to z minus 6 by minus 5. Equation 2 tarekwa. Equation of the lines haibakanda nangi denominator se. Kaino direction ratios ni kwa, direction ratios of the vector ne. And let m1 vector acting along the line L1 or acting parallel to the line L1 is given by minus 3 cap 2 times of k j cap plus 2 times of k. Then m2 vector be a vector parallel to the line L2 whose direction ratios are 3k I cap 1 j cap and minus k cap CP requa. And it is given that the two lines are perpendicular, and so m1 vector will be perpendicular to m2 and their scalar product will be equal to 0. Scalar product lauro, find the scalar product of m1 and m2, and scalar product is given by minus 3 into 3k minus 9k. 2k into 1 is equal to plus 2k plus 2 into minus 5 minus 10 is equal to 0. And find the difference of minus 9k plus 2k, which is equal to minus 7k minus 10 is equal to 0. Minus 7k 10 se transpose tausi plus 10 tareko, and dividing both sides by the coefficient of k. Coefficient of k is equal to minus 7 minus 10 by 7. Sinangi kaino equation nangi k gi value duniko. Angka se kamai hot kani hai taragadi line 1 the parallel of the vector iro, line L2 do the parallel of a vector iro if the two lines are perpendicular, which implies that m1 will be perpendicular to m2. Nangi vector anisina perpendicular already scalar product se kya tani haiba 0 tani bako. Stenang theta gi value se 90 tagrani and cos 90 degree di 0 chale ko. Next question. Question number 7. Find the vector equation of the line. Find the vector equation of the line passing through 1, 2, 3. 1, 2, 3 faraga satpakwa and perpendicular to a plane. Equation of the plane is r vector dot ik plus 2 times of j minus 5k k plus 9 is equal to 0. Nangi equation of the plane puthok equation of the line equal line sin a point ama faraga satle atopa plane ama the perpendicular tai hai. Tangi question number 7. Simo yengsiko. Chinangi required line duniko. Required line si the point A habam laire. If this line L is passing through point A with coordinates 1, 2, 3, and this line is perpendicular to a plane. Plane ama the perpendicular tare. The plane to the normal oiba n vector siga line siga the parallel oina taiko. Parallel oina fangeba. Let A coordinates 1, 2, 3 be a point on the line which is perpendicular to the plane. Equation of the plane is r vector dot ik plus 2 times of j minus 5k k plus 9 is equal to 0. We have a vector. Position vector of the given point is equal to 1 I cap 2 j k plus 3 times of k. Since the line is perpendicular to the plane, so the vector parallel to the line is the normal to the plane. Si normal si tazareko. And therefore, the equation of the line is r vector equals to a vector plus lambda times of n vector. Then write the components of a, write the components of n vector. And this equation will represent the equation of the required line. Nangi darkar oriba equation of the line dugi equation jisina represent tawreko. Nangi line sida ek tawriba vector se n oihale aduga mangonda leiba any point sina a vector no ore. Next question is question number 12. Question pasiko. Find the coordinates of the point where the line through the point 3 minus 4 minus 5 and 2 minus 3 minus 1 crosses the plane 2x plus y plus z is equal to 7. Nangi sigi line am laidoine. Line a point kya faraga sali point ani faraga sali ko. 3 minus 4 minus 5 2 minus 3 1. Sigi point ani se faraga satpa lines in a plane amada cross tawba nangi point of intersection do. The point of intersection of the line passing through this given 2 points in the plane. Adugi point of intersection dugi coordinates se puthokadavani ko. Hoje khoina tawduise. Aduni ihan hanbada equation of the line igani. Equation of the line passing through the two given points. Aina maming loin thole ko. ꯑꯍꯥꯟꯕꯒꯤꯁꯦ point A ꯅꯤ ꯑꯅꯤꯁꯨꯕꯒꯤꯁꯤꯅ point B ꯗꯣ represent ꯇꯧꯔꯦꯀꯣ plane ꯑꯃ ꯂꯩꯔꯦ ꯁꯤꯒꯤ line A ꯒ B ꯒ point ꯁꯦ ꯐꯥꯎꯔꯒ ꯆꯠꯄ ꯅꯪ line ꯑꯃ ꯌꯦꯛꯑꯣꯕ ꯁꯤꯒꯤ point C ꯁꯦ figure ꯁꯤꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ C is the point of intersection of the line passing through A and the B and the plane sida ꯑꯩꯈꯣꯏꯅ ꯄꯨꯊꯣꯛꯇꯣꯏꯁꯦ ꯀꯩꯅꯣ now we are going to find the coordinates of point C sigi C sigi coordinate puthokadabane hause akhoi tawduse ko let A represent the first point B represent the second point and now write the equation of the line passing through the point A and the B A ga B ga faraga satpa nangi equation of the line is ko hause akhoi point A ga point B ga faraga satpa equation of the line se karamba formula na pirakani habakanda x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1 sina pirani ko x1 y1 aduga x2 y2 x1 y1 z1 sina coordinates of A x2 y2 z2 sina coordinates of B oigadamni ko x minus x1 3 hape x2 2 tare ko 2 minus 3 then y minus y1 value of y1 minus 4 minus minus plus tare and minus 3 minus 4 minus 3 minus minus plus tare ko which is equal to z minus z1 value of z1 is equal to minus 5 minus minus plus tare ko and mathangda 1 minus 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 plus 5 phangani the nangi equation of the line se kariga manare x minus 3 by minus 1 y plus 4 by plus 1 and the z plus 5 divided by 6 is equal to kc kc any constant ni ko nangi first expression second expression third expression se same ratio o have same ratio se constant ki o hele the by solving this equation we get x is equal to x minus 3 minus 1 se k ga mana halo du x is solve to se ko minus k plus 3 next y is equal to k transpose already minus 4 tare ko z ki value 6 times of k minus 5 so minus xyz put ho since the coordinates of any point on the line passing through A and B is of the form kai gi form the legani xyz x ki value se minus k plus 3 y is equal to k minus 4 and z is equal to 6k minus 5 nangi point A B faraga satpa line to the leba any point gi coordinates sigi form the legani ba tuna ngasai figure du gi matungina let C be the point of intersection of the line passing through A and the B and the plane equation of the plane is 2x plus y plus z is equal to 7 point of intersection do C ne na khale ko and so the coordinates of C haibasidi nangi line to the sulegani plane the sulegani ko line the later the coordinates of C will be minus k plus 3 k minus 4 6 times of k minus 5 sigi mong de la aniba and also since the point C line so lies on the plane the sulebam to e ko plane the later the coordinates of C must satisfy the plane equation satisfy to bam to e that is 2x plus y plus z 7 see the x y z ki coordinates of C na sinba madam the left hand side will be equal to right hand side wigadam ni ko since the point C lies so on the plane and so it must satisfy the plane equation that is when substituting the coordinates of C in this equation we get left hand side is equal to right hand side ani se managadabani ko 2 minus k plus 3 k minus 4 6 times of k minus 5 is equal to 7 minus 2k 6k minus 4 6k minus 5 5k lere ko 6k nang k se solve tau to sigi 6 ka siga di kya dhare 7 2 log thokra di 5k duga 6 am lere ko minus 4 ka minus 5 ka minus 9 tare 7 ore dugi nangi k ga constant ga separate tau siko 5k 7 ani se subtract tau buda minus 3 am phangani transpose tau di plus phangi ko is equal to k and dividing both sides by 5 value of k is equal to plus 2 hosina k gi value phangi ko k se constant amani putting the value of this k in the C in the coordinates of C sida hapse ko C will be equal to minus 2 plus 3 2 minus 4 and 6 into 2 minus 5 C expression ma'am gi value say 1 minus 2 7 tare ko tuna nangi line ani line A ga B ga forest at pa line duga plane duga nangi intersect tawise chani intersect tawnariba point C ki coordinates se kya oire heba 1 minus 2 7 ꯁꯤ ꯇꯥꯔꯦꯕ. For today let's end here.